here, and this is the 2000 AIME 1 problem number 1. Find the least positive integer n such that no matter how 10 to the power of n is expressed as the product of any two positive integers, at least one of those two integers contains the digit 0. So first, let's start experimenting. Least positive, so let's start with 1. So 10 to the power of 1 can be written as, prime factorization is basically 5 to the 1 times 2 to 1. So for this example, we can see that we can express 10 as 5 times 2 such that none of them contain the digit 0. So next we do 10 squared, which will be 5 squared times 2 squared. So over here, again, nothing will consider 5 squared times 2 squared is 25 times 4, none of them contain 0. So from now, you probably see what's going on, right? Because to even get a 0, all we have to do is we have to pair, why am I putting 3? All we have to do is we have to pair 1 5 with 1 2. And then that'll give us a 0, which will immediately pass. So really the question is, when we split it as 5 to the power times 2 to the power, when do we have such that 5 to the power or 2 to the power is equal to 0? And we want to find the least positive n that satisfies this. So that being said, let's make a chart. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Alright, with 2 to the n, 5 to the n. Okay, so like this. So now let's just compute. So 2, 5, 4, 25, 8, 125, 16, 625, 32, 31, 25, 64, 15,625, 7 would be 128, and then 128, let's see, 15,625 times 5 would be 75,000 plus 3,125, which is 78,125. And then we have 256 over here. Really, it's pretty obvious that we're going to reach a 5 to the n where it has a 0 before a 2 to the n where it has a 0. So I think I don't know any more powers of 5, so let's do the multiplication. 1, 2, 5. Then we need to multiply this by 5. And then multiplying gives us 5, 2, 2, 1, 6, 0, 4, 9. Okay, so there's 390,625, which indeed does have a 0. So we know that when we do 10 to the power of 8, we can always express it such that one of the integers contains a 0. So our answer is 8, and we are done.